Good day, folks. This is video number 7 in the playlist, which is under motion design in 3D experience, the kinematics videos. I have done this problem many times. I will show you later where the references are, but it's a slider crank mechanism. It is a simplified version of, for example, uh, it- uh, the mechanism behind an internal combustion engine. But anyway, it's made of an assembly of four pieces: a base, crank, conrod, and piston. Now, the dimensions are given here. I'm not interested in the dynamic or force calculation. All I want to do is to do a kinematic one. And what that means is that, for example, I specify the speed of the crank, the motor that turns the crank, and I want to get the acceleration of the piston, etc., etc. I'm not interested in forces. Uh, so I'll make all dimensions in inches, but that's really irrelevant because we're interested only in velocity and acceleration, stuff like that. Now, this problem was done in several other playlists for different reasons. For example, I have a playlist which actually uses mechanical systems design, okay, and mechanical systems experience, which was done recently, maybe in the last, in 2000, late 2024, and I have solved this problem. But remember, mechanical systems design is not the same as motion design. It's a different application. So I want to repeat it here again using motion design. And then I've also done it in the CATIA V5 uh, DMU app or workbench, and it's right there. Okay, so let's go ahead. And the approach that I'm going to take in doing this problem is top-down approach. In other words, I make all the parts right in front of your eyes in the assembly. I'm not going to make them separately and bring them in and then put them together. Okay. The problem is simple enough that this is going to work. The only thing is that let me go change my units here from meter to inches, I believe. Yeah, from meter. Yeah, we go length from. See for a second. Okay. Where is this thing? Meter to inches, and then okay. Good. Let me make the base first. So insert 3D part. 3D part, and I'm going to call this thing the base. If this stuff is too easy for you and you know how to do these things, just fast forward until I basically create my go-to motion design. But okay, so on that vertical plane, I will sketch. So what I will sketch is basically this square here, and then or that square back there, and then I pad it, okay? So let me go ahead. The dimensions are going to be one by one. All right, exit, and then pad it by 12 inches. Okay, then I'm going to make that pin on the right side of this face. The location of it, although of course it affects some stuff, but it's not critical for our purpose. And I'll just randomly select at this point. Let me just dimension these things. So this is going to be radius 0.25. All right. And that's pretty much it. Exit. And then pad it by 0.5. Okay, that takes care of our base. And we go all the way to the top. Let me do the crank next. Call this thing crank. All right, let's make it. Now I can draw all that stuff that you see there, but I'll do it a different way in the following sense. So on this plane, I will sketch. I want to make my job easier. That's pretty much it. Then I'm going to project that circle. I'm going to project that circle. Instead of drawing a circle, you know, and dimensioning it, I'm going to project that circle. And now I continue with the rest of the thing. So view from the front. Okay, let's go ahead and do it. So with the profile, and I'll clean it up in just a minute. We'll dimension it later. Okay, let's do a few things here. First of all, I want this and that to be concentric. Control that. And I like this dialog box, concentric. Okay, that's good. All right. And I want this and this to be tangent to each other. Either that or this and this to be parallel. Either way, this control that be parallel. Okay, now that forces this to be tangent. I was hoping so, but let's make this thing tangent to that. I was hoping that it forces it to be tangent, but I guess not. There we are. Okay, very good. Now let me draw the circle on at the other end. Okay, and dimension it. The radius of that thing was 0.25, I believe. I'm sure those things are concentric. If not, you can make it maybe not. I don't know. This at least tangent. I don't know. This control that. Maybe it was faster if you actually drew it, but that's okay. Yeah. Excellent. Exit. And then pad it by, oh, dimension. I forgot dimensions here. Let's go back. Let's go back here. Let's put some dimensions. So the dimension between this point and that point is, I believe, 3.5. Okay, that looks good. Exit, and I'll pad it in the other direction by, it looks like I forgot to specify that in the drawing, but let's see for a second. If I look at that, yeah, so why don't we make this thing Remember this, the thickness of that pin was point, the length of that pin was 0.5, so I'll make this in 0.25. So something is missing here. Good, no problem. Now that's what I mean by top-down approach. I do it as I look at the rest of the model. So we go all the way to the top. Why don't we save this thing? Then we're going to create the connecting rod. Okay, so insert 3D part. Call this thing Conrod. Conrod and Conrod. Okay, and let's go make it. Okay. Now, just like before, what I'm going to do, we look at this slide, so I will draw it on this face. Okay, go ahead and do that. So on this face, I will sketch. So why don't we project that circle? Yeah, project that circle. There we are. And I'm going to proceed from this point on. Okay, uh, let's draw the rest of the profile of that thing. I'll dimension it later. Okay, let's do a few cleanup here. First of all, I want this and that to be concentric to each other. Yeah. So this control that to be concentric. Very good. And I think about this and that to be tangent to each other. That's pretty much it. Okay. I'm pretty sure this and that are tangent to each other also. Yeah. Well, why don't we do that? Very good. Okay, now I want to circle at this end. Why don't I do that? Circle over there. I'll make the same dimension as the other circle, which I believe was 0.25. Yeah. And the length of this connecting rod, so I go from that center to this center, I believe to be 6.5. Very good. Now notice that if I exit this, and I make a pad, uh, both of these are going to be holes. If you insist of making a pin here and a hole there, and I insist on doing that because if you don't know it, if you're a criteria user, you probably know that. But I want to show you how to make a hole at one end and basically protrusion at the other end. So that is not called pad, it's called multi-pad. Let's see if we can find it. Right here, multi-pad. See that? Multi-pad. Otherwise, you pad it, you go draw a circle on it, and then draw another circle and pad it again. But I want to insist on doing this multi-pad. So it tells you that you have three curves here. And if you left it as 0, you get a hole. But if you changed it, for example, if you look at this one, Let me see for a second. We can check find out what is what. So for example, look here. Obviously, that's going to be the whole. This is going to be the whole part. Okay. So the whole part means that the whole connecting rod. I want that thing to be 0.25. So let me change that thing to be 0.25, and I want it in go in the other direction. Good. Now this fellow, if you made it a little bit bigger, is the other end. I want this thing to be 0, just like before. Oops, 0. And this must be the side, that side here. And I want that thing to be, let's say, it was uh, pad length 0.5. So, yeah, we can change these things later on if we don't like it. So here's going to be 0.5 and flip it so it goes into the hole. Preview. That's the way we want it to be. Okay, the only thing is that yeah, that fellow, this one, I want it to be in the other direction. This one, yeah. Let's see if it works. Okay, so that being the case, that fellow, I want it to be in the other direction. Let's see. We can change it. You know what? I rather flip that guy, and then we're gonna assemble this properly so it looks better. That's fine, no problem. Okay, we go all the way to the top. Now insert the piston. Right click, insert, 3D part, piston. As I said, if these are too elementary for you, you can just fast forward. Piston and piston. Okay, let's go make it. Double click. All right. So why don't we do it on, sure, we can make it on that face. It's just a box basically. Doesn't matter where it is. So this is going to be 1. And this is going to be 1. If it is 1. Good. Exit. See how it looks like. And pad it up. There you go. The other direction by a height of 1. Okay, and I need some kind of a pin over here. So on that face, I will sketch a circle. You can make it to be right at the center, or etc. It doesn't matter. And this radius to be 0.25. Okay, exit. And why don't I pad it? Yeah, that's fine. If necessary, I'm going to change it. I'll make this thing a bit longer. 1. Very good. So we go all the way to the top, all the way to the top, and save everything. Okay, now I'm going to assemble. To do that, why don't I move the stuff away from each other? First thing I'm going to do is to actually fix the base. Fix the base. I don't want the base to move, so I'll fix it. Let me collapse these things so that you can see what's happening. The base is fixed. Now I'm going to use, for example, either the compass or manipulate these things to move them around. So I'm going to use the manipulate. So manipulate, translate in this direction. Let's do that. That goes there. This goes here. This goes here. And then we're good. Okay, good. So now let's assemble the crank. Now that's going to be a revolute joint. So it's going to be revolute. And you see that you get a template here. I'm going to use this template, axis and axis, plane and plane, and then later on I have to put a motor there. Remember, I have to put some kind of a motor there to turn it at 60 RPM. So I may need the command, but it's okay. Let's not worry about it right now. Just leave it to it. In 3D, in mechanical systems design, you will need a command there, but we'll see. So we're going to use this. So it's going to be that axis and this axis, that plane and this plane. And for now, I'm going to delete this because I told you that you may not need it. So we say, let's go ahead and do that. And where's the update? Control U. Something is not right here. Let's check that. Axis and axis. Oh, I want this thing to be 0. Right there. Distance to be 0. Say OK. And Control U. Good. Okay. Now we're going to put these two together. So it's going to be another revolute. So another revolute. I'll use the same template right there. This axis and this axis. Okay, and later on for the plane, this plane and that plane, if it doesn't look right, we're going to flip some of the directions. So I don't need this. Delete it, and then say OK, and then Control U. Or maybe that again, I forgot that distance. I want it to be 0. Yeah. Say OK. Control U. There we are. And remember, I said that I may have to flip it, and I do. So double click on this revolute. For the faces, I will flip. Let's see. Control U. Actually, I wanted the other fellow to be flipped. So let's go ahead and let's check it out. Control U. Ah, that's okay. No problem. Yeah, very good. And now we're going to do a prismatic. Put this thing over there. Prismatic. I use, again, it doesn't matter. I use, for example, sure, axis, line, plane, plane. Yeah, yeah, just do that. This line and that line. This plane and that plane. And I don't need this. And I say OK. And finally, I want to put this pin inside of that hole. So that's going to be a cylindrical. Doesn't matter which one. So I use this. So this axis and that axis. And actually, that's all we need. You don't need any of these. Control U. The updating, I have to do that manually, but if you want, you can go to the settings and fix it. Okay, so let's go ahead and check first of all, see if these are wrong. I don't like any of these planes, so why don't I hide them all? Control F, all the planes. Find me all the planes, select them, and then I'm going to hide them. Otherwise, you have to go through it one by one and hide them. Now I can check these constraints, these joints right here, but I'm not going to do that. I'm going to go to motion design and check it there. How about that? Okay, let's do a quick save here. All right, and you know what? What I like to change these colors here. So this one, I'm going to make this to orange. Conrad, I'm going to make it green. Piston, make it blue. All right, and the base yellow. Just so it looks nicer, that's all. Very good. Okay, so this is just an assembly and creating assembly constraints. Now I'm going to go to motion design. In the previous playlist, I had gone to mechanical systems design and then created my joints and things like that. But here I'm going to go to motion design. Click on it. All right, it says it's a new mechanism. Is this what you want to call it? Sure, you can call it anything you want. I can call this thing, for example, my slider crank motion, it's up to you. But just, that's fine. Just say, okay, good. Now, notice that markers have been created. And if I don't like to see the markers, I can just click on this icon, show markers. And remember where this is coming from. If I close this thing, and you go to tools, there is app options, and this thing comes out. You don't want to see it? Just hide them. Want to see them? Okay, good. I hid them. Now, there in the mechanism, there is this thing called Kinematics Player. You click on it, and it will give you knobs which associate different degrees of freedom. For example, this one. That is this. Yeah? Good. That one is the other revolution. It shows you that these are all related. Now, this one doesn't do anything, and the reason is that that's a cylindrical joint over here, okay? When when the block moves, for example, it pulls that thing with it because the axes were constrained. So that's okay, cancel. Good. All right, what have we got here? Automatically, look what happened here. Automatically, a dynamic scenario has been created for me. Okay, you click on it. I don't want dynamics. I'm on kinematic, and that's pretty much it. I don't usually fool around with these things, but advanced setting, position, and velocity acceleration, that's fine. So notice that what I did, first of all, I changed that from dynamic to kinematic. Now, if you're going to put a motor here, you need to create a driver. So you scroll down in mechanism, and we have talked about these things in tutorials or videos 1 through I don't know, 7, 6. So we have done this thing many times. But there is a driver here. Let's find it. There, driver. Okay. It says which joint? Well, I want this revolute joint here. There was a revolute joint there. So let's go to our joints. It was the first one between the base and the crank. See that? It was this right there, right there. Select it. Now we're going to say that, for example, this is going to be turning at a constant speed. So I'm going to click on this function here. See that? See this? You click. What is it that I want to control? The angle. That's good. And what is it that I want uh, to to do? It's going to be constant speed. That's fine. But actually, I want to I want to control the angular velocity of that. Select it, okay? And the angular velocity is 60 RPM, right? So it's going to be, I'm going to put down 60 RPM has to be written like this. Turn underscore minute, or you can convert the stuff and do it yourself. Turn, I believe I don't think they have changed these things, but that's okay. Show plot. There's nothing to show basically. That's already 6.283, 2 pi radians per second, right? Angular velocity, that's good. Say okay. Very good. Say okay. And now we're gonna, you can preview it first. Here's the preview. Give it time. Okay, very good. Exit the preview. By the way, the default time duration is 5 seconds. So in the previous I mean, for example, mechanical system design, and prior to that in TLV 5 is 10 seconds, but then we changed it to 5 here. But I want to do it over 2 seconds. And now I can also add stuff here. For example, I can add kinematic probes. I can add probes here, but I'm not going to. Here's the probe. Remember the old CATIA program? DMU, you added probes. If you want, you can do that, but I'm not going to do it. So let's keep it like this for now. Uh, what is it that you want? Oh, run it. So under simulation, run this. Okay, it's finished. Now let's do the animation first. You go to results, select the result that you want. It's that last kinematic step 1, and do the animation. And let's do it continuously. And you can slow things down, etc., etc. Done it? Now we go to 2D plot. What is it that you want to plot? For example, let's say that we want to do the acceleration of the block. So we first of all use the filter here. So I want you to show me stuff about the block. Where's the block? Oh, piston. I call it a piston. And what is it that I want to see? For example, I want to see the acceleration that'll be in the x direction. Show it to me. There we are. You can say, okay, now also show to me velocity. Add it. There we are. You can hide these things, the ones that you don't want. You can delete stuff. For example, let's look at position. There we are. Okay, let's do a couple other things. What if you wanted to find a trace of that? I believe the trace of, for example, a point. What is the path that a particular point take? So let me see if I have a point here. Do I have a point? Let me see if I have a point. Otherwise, I go and create a point. Yeah. So I don't have a point. So let me actually, I'm going to run this thing again. Let me go to, for example, what is this? Sure. Let me go to this part, Conrad. While I'm at it, I click create a point. For example, how about the centroid of that face? I'm too lazy to do that. Centroid of that face, right there, you can see that. A point has been created. Go back to scenario. Okay, and I believe I have to run this thing to be able to plot the trace. I'm not absolutely sure, but anyway, let's run it. Go to simulation, run it. Okay, good. Now go to results. Let me see if I can find the probe here. Not the probe, the trace. I forgot simulation. Nope. Results. View. Tools. Oh, actually, what I had to do was go mechanism, and the row swept volume. I want the trace right here. Geometric trace. Geometric trace. So easy to forget these things because every all these software they have it in different places. The same essentially program, but interface change, everything changes. Okay, so what is that? I want that point. All right, and then say okay. All right, and let's see. There we are. So it looks like I had to run it again, and there is the trace of that point. In fact, if you animate it, you see that that point will actually follow that path. Okay, let me slow it down. See this point? The centroid of that face is following that path. All right, folks, so that's pretty much it. As I said, I've done this thing many, many times, but of course, when they bring these applications in, new applications in, they move things around. So unless you do it every day, it's kind of hard to know what is it that I have, where do I have to go for the trace, or do I have to run it again or not? Yep. Good luck.